was hoping to do it from Carol's kitchen out there on the roof. It made up and stuff. So I want to welcome you guys. Thanks for coming today and sitting through this. I'll try to make this painless. This is a good class. It's not boring. It's kind of well received everywhere we've done it, and we do this all over the place. My name's Tim Sarge. I'm the sales manager with Air One, so I kind of oversee Illinois and Wisconsin, all the sales reps, and help them out, specifically with MSA more than anything. And this is one of the many things that we do. You guys, most of you know Angelique. She's the sales rep for this area. She's sat through this about 10 times now, so she should be able to teach this. Yeah, my background with meters and stuff is I was a fireman full-time for 32 years. I retired and went full-time with Air One about 3 years ago. And one of my duties at the fire department in Illinois was I ran a hazmat team for about 15 years. So a MAVIS division, we had like 22 towns. And I oversaw the gas detectors and stuff and taught a lot. I worked for a company that taught hazmat. So I've been teaching a lot of hazmat and did a lot of this stuff over the years. And one of the things that when I started selling, when I actually started selling because I was teaching hazmat, that's how I ended up with this job. But I always wanted to impress on everyone, like you have this equipment. And even though you're not on the hazmat team, you used to get guys in our fire department, like you'd try to teach hazmat and they would just shut you off. You're like, I don't need that. It's boring. I can't understand it. Well, it never made sense to me because, yeah, I'm a tech or whatever I was, a hazmat guy. But we all go to the same calls, and you do need to know this stuff. You don't have to know all the ins and outs of hazmat if you're not a hazmat tech or responder. But you go on the same calls. You have to understand why the meters alarm the way they do and how you use them properly. That's everyone's responsibility. So that's what this class is kind of geared toward, is trying to just go over some of the science. And I might lose a few of you talking about some of the PELs and stuff, but there is a reason why I'm trying to teach this stuff today, and I think you'll get that. It's not a sales pitch, so we're not here to try to sell you MSA meters. That's not why we do this class. It's to try to educate you on how the meters work. All the stuff on the table here is what we'll kind of go over, and as long as we're in this little room, I'll just sit. There's no reason to stand up and do all this, but we're going to go over some of the science, and some of you guys may know this stuff backward and forward. I'm not trying to insult anyone with intelligence, but we're going to go over some basic stuff that I think will be a good refresher, okay? So I call it gas detection for the fire service. You guys have been on these incidents. You got to pull like a level B response here with Kapler tape, the whole 9 yards, looking for some kind of a spill or some kind of incident. And then you just got your basic firefighter going and checking a sewer. What do you have readings? We have the full gamut of what we do. Confined space rescue is a hazmat incident. You guys deal with probably a lot of agricultural stuff. There's stuff leaking or spilled. And so you see all these type of thing. You have rail going through here. Okay, so you have the possibility of any type of incident that could happen here. So it's important to know some of these things. Okay. We're going to go over all the different meters today, from a 4 or 5 gas pump gas detector to a 4 gas diffusion. We're going to talk about that, to a single gas detector. Okay. There's also what's called area monitors. This is an area monitor. This is meant to remotely monitor for 4 gases and send that signal to a command post or to a separate area. This is something you would use and stick it on light poles. This will run for 60 days. This is an area monitor. This is what's called the Area Ray. That's a different brand, but Ray makes what's called an Area Ray. The same thing. It's got an antenna on it, sends a signal out. An area rays monitor for gamma radiation and PID and stuff like that. This is a more simpler device that does that. Okay, we're going to talk about the calibration station versus manual calibration, and you can do it either way. They both do the exact same thing. Okay, so we'll hit on all these things today. Gas detection, emergency response. These are all your gases. Now I could ask any of you to rattle all those off, and if you get them all right, ready to check. I have to look at a lot of them. It's double. But these are the things traditionally that we come across from all our hazard classes that we can come across. These are the most common industrial chemicals, things that you guys would respond to. Low oxygen, okay, or high oxygen. LEL or explosive. CO, carbon monoxide, very common. H2S, hydrogen sulfide. So those 4 are what all these meters have in them. That's what your gas detectors here have in them. Then you get into the more exotic gases that we deal with. HCN, hydrogen cyanide. Very common now in firefighting that we monitor for that after a fire. NO2, nitrous oxide. Okay, it's common industrial chemical. SO2, sulfur dioxide. You may have plants that have that stuff. It's nasty stuff, and if you have to look for it, you need to monitor exactly what's there. Chlorine, Cl2, NH3, nitrogen. What is NH3? I gotta look that one up. And pH3 is phosphine. Phosphine is very common with meth labs. Okay, very nasty stuff at real low levels. So we're gonna talk about all of those. Oh, NH3 is ammonia. I'm sorry, I had a brain block. NH3 is ammonia. I used to remember all these things. I'm getting old. We'll start with a single gas. So single gas detectors, you probably again. Let me ask you, what do you guys have now?
Our 4 gases are Draeger,
You have Draeger 4 gas.
and then what are the ones on the bottom?
On your, you have EMS bag monitors.
Yeah.
That's real common. Single gas of some sort, probably CO. What brand? It doesn't
I don't
matter.
know what kind,
Yeah.
Right, yes.
Okay, they all kind of operate, and the alarm set points are pretty much the same. So you're running with a 4 gas. Is it a pumped instrument or just diffusion? Just diffusion. There's no pump that runs on it. Okay, so you have a 4 gas and then a single gas, probably a CO. This is the most common thing you see is a CO. These are very common up here. Milwaukee started that program years ago where they put a single gas CO on all their EMS bags. Left them on all the time. And just went into houses for EMS calls, and they were getting hits on alarming all the time. Okay? Found in CO in places that you didn't expect it. So we're going to talk more about the gas and the settings in a little bit. We try to sell a single gas now if people want to do hydrogen cyanide. So we have a lot of fire departments now. They'll buy one HCN hydrogen cyanide meter. After the fire's out, when the guys are going to start taking their masks off there and overhaul, they'll go in and actually see how much HCN. We try to do it on a single gas separate meter for a couple reasons, and I'll talk about that when we get to HCN. Okay. And then you have people that buy them for chlorine, combustible specifically, and H2S. If you have a chlorine facility, if it has chlorine gas tanks, 100-pound chlorine cylinders, we try to get you to buy a single gas chlorine and not put it in your 4 gas. There's a reason for that, okay? If you get an incident with chlorine and you have to go in and monitor for your zones, you're only exposing a $400 or $500 meter to that chlorine, which can, at the end of that incident, you might have to trash it. It might be shot. It'll work, but you'll never clean it enough to get it out of there. If you put that stuff into here, you're going to trash a $1,500 instrument. So we do.
That was my question on the single one after a fire. Is that trash?
No, not after a fire, not HCN. No, this is multiple use. Yeah, you can just clean it. It's easier to clean. One of the reasons we do the HCN as a single gas is if I'm going to calibrate a 4 gas with HCN in it, I have to add another can of gas, cal gas, and you only really have to calibrate an HCN meter maybe twice a year, and the cal gas will last much longer. If you mix it in and have cal gas for everything, it's a lot more expensive to calibrate it all the time. It costs you a lot more money. So you save a lot of money by putting it in a single gas. The other thing is you find a lot of times when they bring this into a fire, say after a fire, it gets really dirty and shitted up. So it's a little bit better to keep this one out of all that crap and just use this. And you can clean this and decon it and have it in a thing separate. So money-wise, it's cheaper to buy it this way. You'll have more problems with the HCN being in here and using it all the time. So we try to separate them, have a specialty, especially chlorine. If anyone wants to put chlorine in a 4 gas and make it a 5 gas, I try to talk them out of it. Because once you bring that chlorine into that instrument, you could mess the instrument up permanently and have to get a new one. You know, if it's a spiller, fine, you bill them for it, whatever. But it's just cost-wise, it's a little bit better to have a single gas HCN. Okay. 4 gas detection. So you go from diffuse to pump. So these are MSA meters, obviously. This is called an Altair 5X. This is a 4 gas, which I can add a 5th. I can either add a PID into this or a 5th gas. Okay. So it's a 4 gas that has the ability to have 5. This is an Altair 4X. This is a 4 gas meter. Now, the one thing you'll notice on the front here, the 4 gas detector, there's 3 sensor spots. Okay. That's because we use one sensor for H2S and CO. All right, I'm going to pass these around. These three sensors are what's in these meters. Okay, so a 4-gas meter has 3 sensors because we use one for both toxins. Okay, you've got an LEL, which we'll talk about that in a little bit. In length, we have an oxygen sensor, and then what's called a dual tox. And you notice on the top it has 2 holes. It's monitoring for 2 separate gases. So these are the sensors. A sensors, now you guys have been around for a while. You remember when an oxygen sensor would only last 2 years if you were lucky. LEL sensors, 2 years, you'd start having failures and you couldn't calibrate. You know, you're getting warranties now on sensors for 4 years with an expected life of 5. So sensors have come a long way. There's one thing about gas detectors, the way sensors are made now are far advanced than what they used to be. So you're getting longer life out of this stuff. Remember, sensors used to leak all the time. You'd open up a meter, after 3 years, if you didn't maintain it and stuff, it'll be leaked on the board and it cashed out the meter. You have to buy a new board. You don't see that anymore. It just doesn't happen unless there's a defect of some sort. The nice thing with MSA, we make our own sensors. We actually make our sensors. So they're made here. So we kind of can control that. Some of the other stuff that's out there, a lot of the sensors come from Europe. And that's been a big problem lately because you can't get them. So we were lucky to have that going for us. But it's nice to make your own sensors because you kind of can control how your meters act and respond and things like that. So a 4-gas diffusion instrument, diffusion being that the molecules in the air that we're monitoring for are just passing over those sensors by diffusion. You're walking around the room and that gas is going in there just naturally, okay? And it'll find its way in there. It doesn't have to be forced in. A pumped meter, there's an internal pump that actually pulls that sample. This one's turned off, and it brings the sample in. You have to have a pumped meter in order to get a remote sample. So if I want to bring a sample in from this tip, wherever I have that tip, I need that pump. This one here will not do that. Now, we do make a pump that has a cap, just like the calibration cap that snaps on here. And then there's a pump where the pump is located in the probe. So you have a sample line, and then the 4X has a pumped probe that you can buy, okay? So you can make a diffusion instrument into a pumped instrument. It is possible. Now, the question a lot of people ask is a pumped gas detector quicker to respond than a diffusion? No. They actually respond the exact same time. The T90 time, the time for a 90% accurate, is exactly the same, 45 seconds. So they work exactly the same. All you're doing is forcing the air over the sensors, but they don't react any quicker. Some people think these act quicker, and they don't. Okay, this is just to pull a remote sample. Area monitors we talked about. So this is the one we make. This is called an iOS 360. What's nice about this meter, it monitors 4 gases. This will run for 60 days. So I can turn this on. There's a giant magnet in here, which attributes all the weight. I can stick that to a light pole and just leave it there for an incident. So if you had an incident in town, you could be monitoring your zones, and then I can actually pick those up on a cell phone. So we have an app, runs on the phone. It'll pick up all the 360s nearby. It'll actually show you where they're at on a map. So if you forgot where you stuck it, it'll tell you where it's sitting, okay? And then I can pick those up, and I can actually read them. So it's a nice little system. It's meant to go against the area array. We don't sell these a ton to fire departments. We sell them more to a hazmat team. So the hazmat team will have 6 of those in a Pelican case, and they can just bring them up, stick them around, leave them. The incident's over, the fire department goes home, and they leave them, okay? They're just kind of up there.
Are they shot after 60 days?
No, the battery it's a 60-day battery.
So do you sell them to factories and stuff that have chemicals?
They sell them this was really made for refineries, like oil and gas, and they buy them all the time. And they think they have a leak in a valve, they'll stick a couple around out there and leave them, and then they monitor them remotely and control, and they start to see if they really. So it's a nice system. It's kind of goes against the area rate. A lot of the hazmat teams, like if you had a big hazmat in town, who do you guys call in to help back you up? Do you have a Milwaukee? Yeah, so you have one big level A type team that would come in. And that's the same in Illinois. They'll have the smaller regional teams. the big teams will come in with an area rate type system, and that's what this is. So this isn't something you'd have on a rig to go for every day, but this is a 60-day runtime. So it's a nice little system, and they call those area monitors, and there's quite a bit of them out there. These area arrays, the area array system, like if you go to a lot of the golf tournaments, and you're walking around at a pro golf tournament or something, you'll see area arrays up on top of little buildings and stuff. They actually deploy those at a lot of big incidents. There's terrorism response teams that watch a lot of those big stuff, and they'll put those out there. You know, just like Green Bay, the Packers have a system in the stadium that monitors for a lot of that stuff. A lot of that now they're looking for radiation, because that's what they're more worried about, is somebody going in somehow and bringing in the radiation type stuff. You know, and again, everyone after 9/11, we were buying all kinds of real fancy stuff because we were sure someone was going to do all these things. It hasn't happened yet. God forbid it does. But those systems are still out there. When you're buying a 4-gas meter, that's what an old meter looks like where a sensor leak. Okay, that was a real common problem in the old days. You very rarely ever see that anymore. That was just something we dealt with a lot with the old passports and stuff. You don't see that as much anymore, and sensors have come a long way. When you're buying meters and you're looking at them, ingress protection. So if I say this is IP67, what air packs you guys have? Here, what kind do you wear? You got the G1. So an MSA G1 is IP67. It's rated. Just so you know what that means, IP is ingress protection. How can dust or solid materials and water get into a product? Okay. You buy an Apple Watch, the newest Apple Watch, I think it's IP68, but most of them are IP67. How waterproof are they? So the way IP works is there's two numbers. The six is the first number. That's particulate, dust, things like that. So the first number of an IP rating is particulate. It goes 0 to 6. 0 being no protection, 6 is the highest. The second number is water, okay, liquid or water. It goes from 0 to 8. So the highest IP rating is 68. 6 is the highest, 8 is the highest. These are 67. 67 means this can go underwater up to 3 feet for like 15 minutes. That's what your air packs are, okay? So your air packs, we have a machine now, you can put air packs in there and wash them in a washing machine. 8-minute cycle. There's no pressure or anything, it just washes them. So they're set for that. They're rated for that. So you want to make sure that your gas detectors are at least IP67, okay? That makes a big difference. You don't have to worry about water getting in. It's raining out. There is stuff out there that's people buy something on the internet. They'll say, I bought a 4-gas, it was only $300. And you're like, okay. You look at the spec sheet, it's like IP42 or something. It's like, you know, if it gets wet, it's going to be cash. The water's going to be in the sensors. It's going to be in the board. So you got to make sure you're buying good stuff. Most all of the MSA, the Draeger, Industrial Scientific, that's all IP67. So it's good stuff. It costs more. But it is important to understand what that stuff means. Sensor warranty. This has a 4-year warranty, bumper to bumper, with an expected sensor life of 5 years. So that's, you know, things have come a long way. When I started, it was 1 year on a sensor. If you got 2 years, you were doing it pretty well. It was 1 year. That was 25 years ago. The accuracy, percent of closeness, resolution, obviously the display. The other thing is the response time, what's called the T90 time. And that's the time to get to 90% accurate reading of gas meter. There are gas meters out there that are 15 seconds, and there's some that are 45 seconds. It's an important thing to know, okay? These are 15 seconds. So in 15 seconds, you're going to be 90% accurate. There's some you got to wait 45 full seconds before you're at 90. That's a big difference. Okay, the problem a lot of times in the fire services, especially when you're monitoring like this, who monitors for 45 seconds continuously in one spot? So if you're only waiting 15, 20 seconds, you're never going to get a true reading of what's in the air. But you have to realize that. These are all 15 second. Your Draegers are 15-second response. So 15 seconds minimum to get to 90% of the true reading of it. Okay. Most all of these meters, if you read the manuals, a true reading is usually 30 seconds or 45 seconds. 100% accurate reading. So you got to spend some time if you're really trying to figure out exactly what's there. Okay. Alright, pH paper, you guys carry pH paper in the rigs or anything, you don't have it? Some departments will have pH paper or pH sticks in a little thing. It's something you can invest a few bucks in, have them in the rig, or at least one of the rigs on, on duty. If you get something releasing and you got clouds and stuff, you can make a pH stick. Take a pike pole, the way we did a pH stick, we would take 2 pieces of pH paper about this long, we'd rip 2 pieces off, tape them to the pike pole, the end of the pike pole. You'd wet one with sterile water, like from the ambulance, you just put sterile water on it. You'd have a wet and a dry. The wet one it'll attract solids if there's particulate in the air. The dry one will just pick up vapor, and you just hold that out in front of you as you're entering the area. It'll react before you're in the area. Okay, you'll get a little bit of a warning. So if you're in a plume, you'll see it change colors. Some people will put a piece of fire line tape on there as well to watch the wind direction, so you know where to look for it. In the old days, I went on a call one time at our high school. The janitor put the acid in the wrong vat in the morning at like 5 in the morning. He took the big thing of whatever the red stuff was and he put it in the wrong thing and it reacted. He filled the place with some kind of crazy acid, gas. And the one janitor went down. They had to drag the janitor out. The other guy dragged him out of there. So they send us in there. This was 1990 or something. And our chief's like, go in there and see what the hell's going on. The whole high school is gassed with this stuff. So me and my partner put our air packs on. We go in there. We walk around. We had a map. I still remember. We didn't know where the pool room was. So we find it and we go in there and we have air packs on. And I'm like, yeah, everything in here, like there was things changing color, from the vape or whatever the stuff was. So we come back out, and I'm like, yeah, chief, I don't know. I said I couldn't tell what it smelled like, but the light, like everything was changing color, the metal in the room and stuff. He's like, that's not good. This is like the old days. And then he's like, hey, come here. He grabs me. My coat, all the snaps on my coat, it turned green. It was reacting that quickly. And I'm like, holy shit. All the snaps on my coat, everything went green, just from being in that atmosphere. But we used to do stuff like that. Like nobody really, we didn't have monitors then. We didn't have pH paper. They used to just tell you, wash it down the sewer. Put enough water on it, it'll go away, You can't do that anymore. You really have to go in now and figure out your zones. You can't put people in those environments. You just would never do that now. We know enough that we don't do that for us. Okay? pH stick is one tool that a lot of people use. You can use it for CBRN CBRN agents are pesticides for human beings, basically. But a lot of that stuff will react with pH paper, or if you have M8 paper, the military, the little pieces of military reaction paper, you can put that on your pH stick as well. Toxic sensors, we talked about those. We use what's called a dual tox. And the way a sensor works basically is there's a membrane on there that tries to keep out what it's not looking for, basically. It tries to keep out any inert type gases, and it's specifically looking for CO or H2S, those molecules. A lot of other gases will cross-sensitize on a sensor, cross-sensitize. So, for instance, hydrogen is a very small molecule. That'll go through all the membranes. So if you have hydrogen-based gas, you'll pick it up on sensors, even if it isn't hydrogen sulfide. We'll talk more about that in a little bit. Okay, hydrogen will go through almost any sensor and it'll react with that sensor. Combustible gas. In the old days, we used to call what was called a Wheatstone bridge. So you basically had a filament that was in that sensor, and you would put an electrical charge on it. As that gas would pass across that sensor, it would burn that air, whatever was in that air that was flammable, and it would put a reaction back to your sensor. So you guys have in the cabinet, I was walking in here, you have an old explosimeter. You guys probably used to use that. You pump that thing. Inside that explosimeter was a Wheatstone bridge. And it would heat up that filament, and you would set that 0. You would calibrate it with that little knob. You'd set it at 0, and then you would pump and pull that air sample in there. And that Wheatstone bridge would burn that sample if it was combustible, and it would give you a reading on the needle. That's basically what still happens today, believe it or not. It's just done electronically from a circuit board. So you're still burning the sample. It's intrinsically safe. It won't blow up the gas, but it'll still burn it. The problem with Wheatstone bridge is what everyone had in the old days is you could foul up that filament. And you would get stuff on the filament and then it wouldn't work right anymore. So if you had a real bad incident with a flammable material or gasoline or something, your meter would be screwed up afterwards. You had to get in there and get it cleaned. A lot of that's been eliminated now. We use what's called a catalytic bead. So basically there's like 2 little beads of platinum in there that are heated up, and the platinum reacts with that explosive material or that combustible material. We use a system with MSA. This is why we get so much life out of them. Every time you turn on a 4-gas, it uses a different bead. So this time it uses this one. You turn it off. Next time it goes to this one. Next time it goes to this one. So we're actually having 2 beads in there, and it gives us more light. But it's basically doing the same thing, but they're less prone to foul up and get coated with gas and stuff like that. They tend to clean themselves, and you don't have as many problems with LER sensors. So the technology's gotten better. SAW technology. Have you guys ever heard of a SAW? SAW mini-CAD or a SAW meter? Especially hazmat teams carry what's called SAW. It's called surface acoustic wave. This is for picking up chemical agents like sarin, mustard, things like that. Real bad stuff. And the way SAW works is it's a sensing, like kind of think of it like a flat board, and there's some material on there that will react when the particles come across. So the SAW brings the gas by this sensor board, and any of those agents will stick to that board and react, and it'll give you a reading. So everything else will pass through, but the chemical agents, the nasty stuff, will stick to it, and it'll give you a reaction. That's called a SAW. Some of the area arrays have SAW technology in it. So if you ever hear someone say, hey, do you have a SAW mini-CAD we want to use for this? That's to try to pinpoint what exactly is in the air. Okay, and it works for chemical agents. PIDs, okay? You guys have a PID? Does around, do you have any idea? Anyone around you have a PID? Okay. The hazmat teams will come in with a PID. So a PID is a lamp. It's actually, that's a picture of our PID lamp. It's got a filament in it. It ionizes a chemical. So as the sample comes through the meter, if this one had a PID, there's like a little different backing on this. It's raised out, and inside there is a lamp. As the sample comes in, it goes on the sensors, and it also passes it across that lamp. If the chemical can be ionized, it has what's called an ionization potential. So most chemicals have an IP, or an ionization potential. That means I can ionize it, and I can see how much is there. This is called a NIOSH pocket, guys. You've seen this book in any of your hazmat classes, okay? The IPs of chemicals are listed in the NIOSH book. So I can look up a chemical, and I'm at a facility, and they say, hey, we have a leak of ethylene dibromide, and we got a pretty significant leak. And you're there with your engine company, you smell something, they show up with a PID, and you're like, yeah, the stuff's here, but this isn't going to tell me how much ethylene dibromide is. I have no way to know what's there, okay? But I can take a PID and see if it has an ionization potential. So I look up that chemical. It has an IP of 9.45 EV. Okay? Here's the problem. Most all PIDs that are out there have a 10.6 EV lamp. That's what almost all of them are. Draeger, Industrial Scientific, MSA, whoever. They're 10.6s. It'll pick up a chemical that has an IP of 10.6 or less. If it's higher than 10.6, the lamp won't pick it up. Okay? They do make an 11.7 lamp, and very few hazmat teams have them. I know Chicago has one. Some of the real nasty stuff that's out there, terrorism-wise, has IPs really high, and they have the 11.7. So the 10.6 is what most all your PIDs are. If I have an IP of this ethylene dibromide of 9.45, will my lamp pick it up if it's a 10.6? Yes. So I'll be able to get a reading on there in parts per million. It'll tell you how many parts per million are there. Okay? Problem with the PID is it'll read any chemical, and it reads them all the same, as long as they can ionize. The problem you'll have is you need to know what the conversion factor is for this chemical versus what's on the PID. And for that, you're going to need like an industrial hygienist or some type of a computer where you can enter it. It'll give you conversion factor. Why would a firefighter on a fire engine really need to do that? You wouldn't. That's a technician level thing. It's a thing to say, all right, this leak occurred in your town, and you bring in the EPA or whoever your, state level response is, and they say, I can still smell this stuff in the neighborhood. I can't get rid of that odor for days, but I want to see if it's safe for the people who go back in their houses. They would have an informed industrial hygienist or someone who really knows their shit come out and say, all right, give me a reading of this stuff on a PID, and then they'll do the calculation and say 8,000 parts per million on a PID is equivalent to 12 parts per million of this stuff in the air, and they will see what the readings are on these books and other science books and say, yeah, people can go back in their house. That's not something anyone in this room would be making that call. But you should know that that's how they do it. They decide what's there, try to quantify what's there, and then figure out if it's safe or not. That's what PIDs are for. They even make a PID that's parts per billion, so you can really fine tune that. And you may have a guy walking around, you'll see him with a big device with a sensor on it. He's probably got a flame ionization or a PID or a PPB, and he's trying to figure out what's there. Those are higher level responses. Radiation monitors. You've seen some of these. Some of you guys have been around for a while. These look familiar. Okay, the CDV 700s. We used to have these in all the firehouses. When I started, we used to have those things. They were always in a locker somewhere in the back room. And once a year, someone would bring them out and they try to explain the radiation. I don't try to even go into radiation here because we don't sell radiation meters and I don't know that much about it. I was on a hazmat team where we had these Ludlums over here and we used to do drills on them once a year and we'd all walk out of the drill and guys would be like, I still don't know. I mean, I don't know how to work it. All the settings, and you really got to know what you're talking about with radiation. I was taught by a guy from Argonne Labs who came out one time on an incident that we had in our town. And I said, radiation, no one understands it. And he goes, yeah, it's very complicated, but here's what you need to know, he told me, for radiation, for what you do as a fireman. You should know what your background is in your town. So every town in the U.S., you take out a radiation meter, and it's all different. Depends on where you live. So you guys are up near this Kettle Moraine, okay? That's a whole, natural formation. Up radiation, Angeli pointed out, that's what I'm on. So yeah, what the guy basically told me is if you know the background radiation in your town, try to know that and have it on a card or whatever, what your background is, because it's different everywhere. You ever have an incident and you think you have radiation, you fire up a radiation meter and you have 3 times the background, you have a huge problem, The one thing you remember about radiation is it doesn't travel real far, as a rule. So if you have some kind of radiation in a facility or something, it doesn't travel as far as what you might think. But when you're dealing with gamma, that can go for miles until it hits lead or so many feet of dirt and all that. But a lot of the radiation we deal with is like medical testing radiation, where somebody might drop something, and it kind of tends to stay where it's at. It doesn't travel very far. But if you get into an area and you're picking it up on a meter, you got a big problem. So radiation's a very scary thing. A lot of people in Illinois, they bought FEMA or IEMA bought everybody one of these radiation meters in the middle. The problem with them is they're very complicated to work. You change the settings. There's all these different millirems and radigens and all this stuff. And you really got to know how to work it or it's useless. Because it's telling you there's always radiation. There's always background no matter where you're at on Earth. So you got to be able to interpret that.
It sounds like the levels are still high in Chernobyl. I thought it was safe.
No, they said it's really bad there. Yeah. They were digging ditches there, the military, and they were getting sick like right away.
Yeah,
They put those guys. What a mess. They've got to be sick.
Like you're the most are sending in no things.
Yeah, they don't even want to be there. I mean, the one thing it showed us is the Russian army. Not because they said some of those guys were their best troops and they got their ass kicked.
Yeah.
But the Ukrainians are tough, man.
Yeah.
You see them carrying the mines to
Yeah.
clear the street? The
With
guy had a cigarette in his
mouth.
mouth. He's picking up the landmines and like carrying them, and he had a cigarette, throwing them in the ditch. It's like, that's a tough guy right there.
What we sent in the Chernobyl knowing that the one.
Yeah, like they didn't know what it was. They knew,
Right.
yeah. And then today they blew up like they missiled a nitric acid tank or something by a town. Oh, they're wicked. Okay, so let's go through these kind of quick. all these 4 gas meters, your Draeger meters, they all alarm at a certain set point, okay? All those set points of what these things beep at and alarm at, those come from OSHA PELs. So they're OSHA permissible exposure limits. So OSHA sets, there's 3 big ones that you really should know. Time weighted average, there's short term exposure limit, and IDLH, immediately dangerous to life and health. Time weighted average is an 8-hour day, 40-hour week. So what that means is OSHA, they're published in this book, will say, okay, you work in a factory that has a certain chemical there. You're going to be exposed to it, possibly. If you work 8 hours a day, 40 hours a week at that facility, you can be exposed at up to the time-weighted average of that chemical. So every chemical has a TWA that's published by OSHA, and it's in the NIOSH book. CO has a set TWA, 8 hours a day. So if you work in a factory and there's a forklift that works in the loading dock, you're going to have CO there. As long as it doesn't exceed the time-weighted average, it's okay. The time-weighted average is 25 parts per million. That's what these beep at. That's why they alarm at that. Does that have anything to do with going on a fire call in a house? It really doesn't. Like, that number doesn't mean anything. So a lot of people have like cheat sheets that they'll have on their gas detectors because the alarm set points are OSHA PELs. That's because these are made for workers in, factories and oil and gas and stuff. They'll have some kind of a cheat sheet that they use, so it'll say other numbers. This one here, I have a bunch of these that I collect. This is Chicago's. Reading of 9 parts per million or less is not considered dangerous. So if you go in at CO call and it's 9 parts per million or less, it's okay. It's acceptable. So all you do is reset the detector, tell them to call 911 if it goes off again. Everyone has those limits. Some people use 10, some use 8. What do you guys have here? You have a set point that's considered it's 8. Yeah, a lot of people use 8, and believe it or not, where 8 comes from, because people have asked like where it comes from, and I kind of looked into this. This is the only place I have actually found a reference to this is in Sensit has a card. Sensit uses 9 parts per million, acceptable level of CO in a living space under outdoor ambient conditions. That comes from what's called the ASHRAE. Okay? It's like the American Society of Heating, Refrigeration, and Air Conditioning. That's where it comes from. But that's why they came up with that number. So people that do air conditioning and HVAC have established that in a normal house, you can have up to 8 parts per million. If it's 9, but there's a reason for it. But know the reason that these beep at what they do is OSHA PELs for all the chemicals. So we use these OSHA numbers in the 4 gases, but they don't always necessarily apply to fire. Short-term exposure limit. So all these 4 gas meters have a high alarm and a low alarm. Your Draegers probably have. The high alarm is normally your short-term exposure limit. That's your 15-minute OSHA PEL. The low alarm is your time-weighted average. Doesn't have a lot to do with emergency response. It really doesn't. Because you're on the scene for 15 minutes or whatever on an incident, you're going to be more worried about that high alarm, the short-term exposure, because that is your exposure, okay? So you do need to know that stuff. The IDLH is an important thing for any firefighter should be aware of what IDLH is. If you look at the 2 in, 2 out, which is a federal law, you have to have 2 people outside ready to go if you have 2 people inside. The law actually states that if you have 2 people in the IDLH atmosphere, in firefighting, that's a fire, okay? It's smoke, heat, level, low oxygen, high CO, high whatever is in a fire. That's considered an IDLH. If you're a sewer worker, an IDLH atmosphere is going into a confined space that could have low oxygen or H2S. It all depends on your job, okay? So IDLH is something that we use to know when we're monitoring stuff like this, because we never want to exceed the IDLH. You never want to put someone in the IDLH atmosphere unless they have an air pack on, or depending on what the atmosphere is, turnout gear for a fire. But it all relates back to OSHA, and that comes in this book. Okay, so we do have to know what that stuff and where it comes from. Okay, 2 other things to remember: vapor density. Vapor density applies to gases. So if there's a gas in this room every gas has a vapor density. It's either going to be greater than or less than 1. Air is 1. Okay? So air is always 1. Certain gases have a vapor density of 1.8. That means they're heavier than air. Where are they going to be? Well, they're going to go low. They're going to go lower than air because air is 1. If it's lighter, if it's less than 1, it's going to go up above. Okay, so the lighter the gas, the higher it's going to rise. Right? Carbon monoxide actually has a vapor density slightly less than 1. So it will actually tend to rise. Okay? Propane gas is heavier than air. So propane tends to go down. You ever have your grill not light, where does it always go off? It goes off down, you see it down below you. It doesn't come up in your face. The gas will tend to come out of the grill. It actually goes down around your legs. So when it ignites, you hear whoosh down below. That's vapor density. Okay, that's how things work. Liquids is similar. Density of a liquid, water equals 1. So air equals 1, water equals 1. If a liquid that's spilled has a density of greater than 1, where will it be in water? It'll sink. Lighter than 1, it'll float. So if you had a chemical that spilled and it went in the Rock River, and you showed up there, and you look up that chemical in that truck, and you see that it has a density of greater than 1, where is it in the river? It's down at the bottom. It's going to go down below the water, and you're going to have to realize it's not going to float on top. You might see a sheen from when it went in, but most of that chemical is going to go low. A lot of corrosives and acids are heavier. They go down low. There's a reason when you're behind an acid tanker, it's shaped like this. Okay? It's round. It has rings around it. People think it's ringed and reinforced so that, because it's such a bad chemical. That's not why it is. It's because it's heavy. So if I took acid and I put it in a truck that was shaped like this, elliptical, like an MC306, a tanker, if I put a real heavy acid in that truck, the weight of that chemical would actually cause that thing to fail. It can't hold it. It's too heavy. Okay? So you can't put real heavy liquids in an unreinforced truck. All those things are clues to where we're going to find this stuff. Okay? And you should be aware of it. All right, parts per million, we talked about that. Parts per billion. We'll talk about LEL and UEL in a second. One thing to remember is for something to be 1% in air, you need about 10,000 parts per million. Okay? So it's a general rule of thumb. If you get 1% LEL on here of a combustible, you're probably finding about 10,000 parts per million of that stuff. Okay? That's a general rule. It doesn't apply to every gas exactly, but it's just kind of a rule of thumb. So if you need 2.5% volume in air of methane to be explosive, that's about 25,000 parts per million. 1 is 10,000, 2.5 is 25. Just general stuff that you can kind of try to remember. To get 1% in air, you need about 10,000 parts per million. Why is that important? Have you ever been on a natural gas leak where you go into the house and you smell gas? It smells like gas in there. And you never get a reading on your meter. Okay? You never get a LEL meter reading. And you're like, fuck, I don't know why I'm not getting a reading. It just came up. Why aren't I getting a reading on this thing? I don't understand. A lot of times it's because you can smell it long before you're anywhere near 10,000 parts per million or so. Just to give you an idea, methyl mercaptan, which is what they put in natural gas to make it smell bad, okay? It naturally has no odor. You can smell natural gas at 0.0001 parts per million. You'll actually smell it. Your nose. You're never going to get a reading on here unless you have a PPB, PID. You won't register anything. That's why sometimes you do smell something in a house and you never get a reading. And have you ever had that feeling where you're like, man, I hope this thing's working? Because I smell gas down here. I never got a LEL reading. You never even came close to having enough parts per million to hit that 1%. Okay? So we won't get into this methane. You guys, the gas companies, a lot of times they monitor for methane specifically, so they calibrate their meters to methane. Why do they do that? Because that's what they're looking for. You guys are firefighters. We're looking for anything combustible. It's not always methane. It could be propane. It could be butane. It could be anything. we're going on hazmat incidents that aren't methane, or it's tanker that's flammable material. So we calibrate to pentane. So your meters, and that guy comes from Draeger, he calibrates them to pentane, okay? The reason we do that, I don't want to get too crazy and blow you away here with all this stuff, but people actually really are curious in certain industries why we use pentane. If I calibrate a meter to pentane, and I use Cal Gas at 58 parts per million to reach 10% LEL, here's where it hits the curve, okay, that red line. This is methane here. So if I calibrate to pentane, I'm closer to catching heptane, toluene, other gases. So the reason we calibrate meters to pentane gas is that we capture a lot more flammable materials that way. If we calibrate to methane, we're going to have a lesser reading on other stuff, and we could put ourselves in danger. So I could be picking up toluene at 10% LEL. My meter starts to beep. It actually could be 20% because I'm calibrating out the lower gases, if that makes any sense. So meters are normally always calibrated to pentane. The gas company calibrates to methane because they want to know exactly how much methane is there. That's all they care about. Okay? All right, so oxygen. Your four gases have oxygen. What's low oxygen? Where will it start to alarm at low? 19.5. 19.5% oxygen. Normal oxygen in this room is about 20.8, 20.9. It's 20.8 on here, okay? That's normal oxygen, right? Oxygen enriched, too much oxygen is 23%, okay? So it'll alarm at 23 on the high, 19.5 on the low. That's an OSHA standard, okay? When you get down below 18%, you're going to start having effects. You're going to start being lightheaded. You get down around 16, you're going to pass out. So it doesn't take a lot of oxygen deficiency. The number one cause of deaths in a confined space is oxygen deficiency. That's what kills the most people. Correct the oxygen, give the guy a chance. Okay, you know that. You guys are medics. You're pretty well aware of that. Combustible gas. It's going to explode. That's what we're worried about. We're worried about a combustible gas exploding. I give this story to everybody in the hazmat in classes. City of Chicago Fire Department, about 15 years ago, had a truck company go to a convent, 2 in the morning, convent next to a hospital. They smelled gas. The sister called and said, I smell gas. It's really strong. Truck pulls up. These are old timers, guys that had a ton of time. It was a retirement house. Go in the convent. Hey, sister, it's really strong in the garage. So they walk through the convent. She opens the garage door, and here's all the nun cars, like 5 cars in a big garage. They're all parked in there, and they're like, whoa, man, it was loaded with gas, natural gas. So the 2 guys go down the stairs, and their fire coats are open, What's the other guy do?
It's the light to the garage door.
Hits the door. He's going to clear out the garage. Boom, hits the garage door. Boom, blows the garage. Flashes the gas, blows the 2 guys with the door out onto the driveway. They're rolling around out there. Blew the nun back down the hallway. She's laid out. Here's this guy. It flashed. And the whole point of that is they smelled it. They knew where it was. Have you ever, and I always ask people, can you ever picture a guy you work with that might do that? You can't. I think if you're honest, you just have kind of a brain fart, well, I'll just open the door, okay? You hit that door opener, either that button or that motor firing up, what's it do? It's going to spark, and it'll blow it. If it's at the right concentration, it'll blow it. And it's not to put them down. I mean, there's seasoned guys, nobody thought, yeah, I probably should do that, okay? Opening a door, or a metal door or something, just opening the action to open the door can spark and blow that thing. Flicking a switch, definitely, okay? You always got to be cognizant of what it'll do, and that's blow up. So we monitor LEL. Our meters alarm at 10% LEL. That's the OSHA standard for all meters. So your meters will alarm at 10%. That's an OSHA standard. That's 10% of the lower explosive limit. So the way it works, you're going to have, stand up for this. If I hit the lower explosive limit, so I'm at 100%, I'm at the lower explosive limit, there's enough of that gas to burn, okay? Now theoretically, if there's too much of that material, the combustible material, if I'm too much, it's too rich, there's not enough air, it won't burn, right, theoretically. So in between those two is the flammable range, it'll blow up. The alarm setting on a 4-gas meter is 10% of the way to the LEL. So it alarms right here, 10%. So I'm 1/10 of the way to the getting to the lower explosive limit. My meter, your 4 gases will monitor from 0 to 99. What happens on a Draeger meter when you hit 100% LEL? You don't know. You need to know. You should go find out. And don't feel bad, because a lot of people don't know. We taught a class the other night. Bunch of guys with MSA meters. Our meters, all MSA meters, for years and years and years, they latch at 100%. And yours probably do too. So if you hit 100% LEL, they'll alarm and won't reset, and it'll say something on the meter. It may say 100% and flash, but it'll latch. Ours say 3 X's. Okay, an MSA meter will say XXX, and it won't reset. When you hit the reset, it won't reset. That's telling you that you hit 100% LEL. So you were in an atmosphere that was explosive. And it purposely doesn't let you reset it, because guys will reset it. And they'll stay in there. It could blow up. They want you out of there. You should never be in 100% LEL. There's no reason to be in there. So find out what they do. Look in the book. It'll tell you at 100% LEL. A lot of them have a latching alarm. So that's a safety factor. Okay? Turn this super. The gas company, when they calibrate methane, they calibrate to 2.5% in air. 2.5% methane by volume is 100% LEL. It's the same thing. It's just that you calibrate to a different range. That's all you're doing, but it's the same number. So how many parts per million of gas about do you need to get to 2.5%? 25,000. Okay? Very simple, but it's something that you should know and understand. So when you hear gas people say, oh, we calibrate, one of the reasons that the gas company calibrates to methane, so they know exactly how much, they will send their people in to repair leaks and repair things at more than 10% LEL. They're allowed to do that in the industry. So if they know exactly how much is there, they can send their people in, like around here, and they can work in there. Okay, that's another reason. They want to quantify exactly how much is there, because they can go in at a higher level. They're in that industry. Okay, they have to wear equipment to be protected, but they're allowed to do that. Carbon monoxide, we pretty much know what it is. Incomplete combustion. It mixes with the oxygen molecules and it blocks the transfer of oxygen, so you'll die from being exposed to it. The low alarm is 25 parts per million, which is the time-weighted average. The high alarm is 100. That's the short-term exposure limit. Okay. What's the IDLH? Immediately dangerous to life and health for carbon monoxide. Instantly cause you to have effects. It's 1,200. It's 1,200. So it's really high, okay, but that'll instantly cause you to have an effect. Again, CO is cumulative, so if you're at 400 for 10 minutes, you're going to have the same effects, because it builds up. So it's very dangerous. As it binds with more oxygen molecules, it's going to drop you. So if you're at 100, that's a problem. You should not be in 100 without an SCBA, because it's a cumulative effect, okay? So these time-weighted averages don't always apply to what we do. That's the problem. They really don't. Okay? Hydrogen sulfide, H2S, comes from the decaying of organic material. That can be leaves, dead animals, crap in sewers, actual crap, sewage, raw sewage, things like that, digesters, lift stations. It's there, okay? It's very commonly found in the water treatment plants and things like that. It's found on barges that carry sludge, okay? One of the things about it is it's very dangerous at low levels. The time-weighted average is 10 parts per million. The short-term exposure limit is 15. So they're very close. One of the problems with H2S is You go into an area that has H2S, it smells like rotten egg. It's like a sulfur, nasty smell, okay? And you'll smell it when you calibrate the meters. That's what you smell coming out of there. But what does it do to your sense of smell? It deadens it. So you only smell it for a short time. So these guys will go into a vault to work on something, and they're like, oh man, it smells like shit down there. But then they don't smell it anymore. So in their mind, it's not there, and it deadens your sense of smell. So you can only smell it for a short period of time, and then you don't smell it anymore. It's still there, you just don't smell it. That's what makes it so dangerous, because they don't think they're still in the atmosphere, and they are. Okay, nasty stuff. Hydrogen cyanide, product of burning plastics. If we had a fire in this room was rolling, and these tables and these chairs were all burning, as you extinguish that and they're semi-burning and they're semi-combusted, they will give off HCN. And it's nasty stuff. It's hydrogen cyanide. It'll kill you, okay? And it has effects. The short-term, or the time-weighted average low alarm on HCN is 4.5 parts per million. It's very low. The short-term exposure limit is 10 parts per million. So you can see why we're monitoring for it now in fires. Guys will go back after a house fire and pull the ceiling or they're overhauling, they have a terrible headache. Your head's just pounding, you know. That could be from HCN, the effects of that HCN that you were inhaling. So it's nasty stuff. The IDLH, immediately dangerous for a possible permanent effects, is 50. That's not much, okay? It's not much. So HCN is something that we are starting to monitor for, and rightfully so. All right, I'm going to give you a couple quick 4-gas monitors. You go in with your 4-gas today, your dispatch center calls you and says the CO alarm's going off in the basement, okay? No symptoms, everybody's fine, but you might want to come over here. You get over there, there's no odor, you don't smell anything, but the CO meter in the basement's going off. That's where all their batteries and their material is. One of the dispatchers says, I feel funny. That happens all the time, okay? Dispatchers always feel funny after something happens. They just, I don't know why that is. This is what you got on your 4-gas monitor. You go down the basement, you got oxygen at 20.5, so it's slightly lower than normal. No LEL. You're alarming at 175 parts per million of CO, and your H2S alarm went off. But you don't smell anything. Okay? What do you think it is? What could it be? Check the battery. Why the battery?
Probably on charge.
You probably got a battery that's boiling off, that's gone bad, and it's just charging off. Remember we said earlier, batteries, when they go bad, will a lot of times give off either hydrogen gas or sulfur-based gas. It's not hydrogen sulfide. It's not the right combination, but it's the two compounds of it, right? These sensors will pick up hydrogen. So hydrogen is such a small molecule, it'll go into any sensor and it'll pick it up. It won't burn it because there ain't enough to pick up on an LEL, but the hydrogen's cross-sensitizing on this, and the hydrogen and possibly even the sulfur is hitting on that. Where do you see this a lot? You guys have probably had one there. You've been going on CO calls long enough. The battery backup stuff. Ace in the hole or whatever. Go down that basement and you got a CO alarm and you're trying to figure out where it came from. Turns out to be a battery going on. Okay, it's a very common thing. It's cross-sensitivity that tells you something's wrong, and your oxygen went down because there's enough of those two gases that they're displacing the oxygen, just slightly, okay? Why does the dispatcher feel sick? Because they always do. Okay, respond to a commercial building. You got a worker down in the building in a vat. He was cleaning residue. He's down at the bottom. So you're there responding. You got your 4-gas monitor. You hear something leaking. And he's down. This is what you got. Oxygen 18.6, 2% LEL, 8 CO, and 18 H2S. Okay? What's the number one thing you could do right now based on that to try to save that guy? Get some air in there. Ventilate that vat. Get a fan going in there. If you don't have a flexible tube, whatever. Grab one of your battery-powered fans and hold it blowing fresh air in there. Whatever you can do, use a tarp, whatever you have to do. get air in there. Try to correct the oxygen. And the one thing I would tell you is monitor while you're doing it. So you document, we got 18.6. Get a fan going in there, and a minute later say, we're up to 19.8. A minute later, we're at 20 point, monitor and document what you did. That could be his best chance until you can put people down. Can you put people down there at 18.6? Not without the right equipment, the right breathing apparatus. Because that's IDLH. You can't send them in until you're ready to do that. And that might take a few minutes, but we can try to save him by clearing out that air. So, very common thing that you use a 4-gas. Smell of gas inside a very hot, humid industrial building. It's really hot in there. It's really nasty. Put your monitor. Nothing's alarming because we're not in any of our alarms. But I got slightly less oxygen. I'm picking up an LEL, 6%, and my toxics are 0. Why is the oxygen on? Could be the humidity. Okay? Humidity, any meter that's out there, humidity has a big factor on readings. A super humid factory type building where they're doing stuff where you go in there and you instantly feel uncomfortable, hot, humid, that will cause your oxygen to be off because the humidity actually displaces some of the oxygen. Okay? So that's a very common thing. And the meters don't respond 100% right compared to how they're calibrated in a real humid condition. So that's a common thing. You're getting an LEL reading. The oxygen is being screwed up by the humidity. Just something to keep in mind. And all meters are affected by humidity. Okay? So they're not always 100% accurate when they're super humid. Even a super humid day, you'll see your oxygen will be a little bit lower than it normally is. That's normal. Okay? It happens. Go to a grocery store, truck back into the gas meter, high pressure leak present. This is what you have inside the store. Now on an MSA meter, it's 3 X's. You were at 100% LEL, but know today, go figure out with your mind, what does yours do at 100%? Okay, it should latch. I would think they latch. Most all of them do. They lock on at 100% and they won't reset. You got to turn them off. And that's just to keep you guys safe. That's why we do that. Okay? This we've gotten a ton of lately. I put this in there recently because we have a lot of calls. If you're running with the single gas COs on your medical bags, there's 2 reasons. Originally, we were getting a lot of these where they'll call and say, yeah, the CO meter, we heard it going off. We went out in the bay. We were getting 89 parts per million. Okay? A lot of times what it was, what's normally right under the compartment where your EMS bags are? Batteries. A lot of times it was batteries. The battery was off gassing. Or we'd have CO. You guys go out on a call with the squad. They pull the squad back in, back it in. 10 minutes later, the CO meter is going off. Picking up the CO. That happens. Lately with COVID, we were getting tons of problems with single gas on the bags. From what? Disinfectant. Huge problem. Would you, any of you people up here spraying the ambulances with the backpacks? Okay.
Yeah.
And these things are sitting out, we're having tons of meter problems during that COVID. Big time meter problems. And you bring them in sometimes and the tech would smell them and like, someone sprayed something on here. Once you spray that shit on there and it gets in that membrane, it'll pick it up forever. That's the problem. So you got to be careful when you're deconning the 4-gas meter. Okay. Meth labs. I don't know if you guys have meth labs. Some people that have meth lab problems will buy a phosphine meter because they want to see how much is there. But I put this in there really because phosphine is a byproduct of meth labs, and it's one of the nastiest things they'll find in a meth lab. Look at what the time-weighted average is for phosphine. 0.3 part per million. And the short term is 1 part per million of phosphine, 15 minutes. It's nasty stuff. And they do find it in meth lab. It's a byproduct of meth labs. So we get that a lot in certain areas. I don't know if you have them up here once in a while. Yeah. We've got a couple teams. We have had some police departments buying phosphine. And they'll have it on if they're going to have to go in there. So, some other gases, ammonia, chlorine, sulfur dioxide. Chlorine is 0.5 parts per million of a TWA. That's the low alarm, 1 part per million, so chlorine and phosphine are in the same settings. Ammonia, 25. The other thing about ammonia, remember, is it is explosive at 16% in air. It'll actually explode. So, you had an ammonia leak, and you get to 160,000 parts per million, or 16% in air, it'll actually explode. Okay, and there was a hazmat team in, I think, Texas, that went in, level A entry, on an ammonia leak, and while they were in there, it blew. They got burned up in the soups. So remember that ammonia, if you confine it and you get enough of it, it will explode. Okay, nasty stuff. Radiation, I thought, but don't ask me. I don't know anything about it. 3 times background. Normal background radiation is anywhere from 5 to 20 milligrams, but you got to know what your town is. And you're close to that Kettle Moraine formation, whatever. It could be higher up here. You know, there's radium or whatever that comes out of those things. But know your background. It's different everywhere. It is different everywhere. So 3 times your background, you need help, and you need to call somebody, because that's a bad thing. Humidity, cold weather. Cold weather definitely affects 4-gas meters. So on a super cold day, give it some more time to run before you start to use it. Let it run and normalize. Pass that power across those sensors and let it kind of normalize. Silicones in the rigs. Armorall will affect 4-gas meters. So Armorall will collect on the LEL pins, no matter what brand you have, and it can follow up your sensors. So if you're going to spray Armorall around the rig or detailing it that month or whatever, get the 4-gas out of there and let that clear. If you can smell that Armorall, this thing will pick it up. And it'll pick it up when it's off. There's a charge on those pins all the time, and it'll attract the silicone, and it'll foul up the LEL sensor. Okay, so we get that a lot in the fire service. No calibration. So I asked you earlier, who calibrates them? You have a guy that comes. We go into departments, and they'll say, yeah, he calibrates them, so-and-so, he's on, this certain shift. Oh, yeah, but I don't think he does it very often. So I'll go into places, and they'll be having a problem with a meter, and you'll say, well, get your cal kit. Let me see it. They'll bring out a calibration kit. I've had people set them on the table. MSA meters, Draeger cal kit. And then you take the gas out, and it's the wrong gas. It's been expired for 4 years, and you're like, oh, you calibrate these. Yeah, I can't imagine why they're not working. Cal gas has to be within date because it degrades after a certain. The H2S that's in that gas will degrade the other gases. So you're calibrating the gas that's not accurate. It'll cause nothing but trouble. They'll last forever. If you calibrate meters regularly the right way with the right gas, they will last forever. They just do. You have very few problems with them. If you don't calibrate them and you neglect them, they'll screw them up. Okay? So I got Kenosha. They have the Galaxy system of ours, and they calibrate all the time. CalGas comes with this little ring on it now. It's glued to the top. And what this ring is in this ring, if you pull this thing, you'll see it embedded in the plastic, is an RFID chip. It's got the type of gas, the settings, and the date. So when I screw that into that meter, it picks up the RFID tag and it says that's the right tank. It's green because it's not expired. If it's getting low, it'll turn yellow, close to the expiration date. If it's expired, it'll be red and it won't let you calibrate. So they figured out they want to get all the gas out of the cans because they think they're wasting money. It expires before. They peel these off the new ones and put them on the old ones and use them down until they're empty. I started going in there, and this is where this came from. And I would unscrew the can, and this would fall out. I'm like, why are these falling out all the time? They're glued on, He's like, I don't know, Well, I guess weird, And then finally one guy goes, they're not falling out. We tear them off, the new one. We order a new can, we put it on the old can and get it to 0, and then we put it back on the new can. Only in the fire service. I'm like, they figured out a way around the CalGas. Cross sensitivity, we talked about that. This is a Galaxy system. It tests itself. Okay, that's about $2,400 for that to invest in it. But a lot of departments, what's nice about that is you put the meter in, you push it in, it does everything itself. Calibrates it, gives you a check mark, tells you you're good to go for 30 days. Okay. We talked about the pentane curve. I don't want to get too crazy with that. That's a post gas explosion. My biggest thing with the gas monitoring is you don't have to know every ins and outs of this stuff, but you should know where to go. You know, everyone here responds on a call. You're not necessarily a technician or a branch level hazmat guy, but you should know enough to keep yourself out of trouble and know what these things will do. They'll tell you all kinds of things, whether you have a Draeger or Industrial Scientific or an MSA. They don't always tell you exactly what you have, but they tell you something's there. Okay? When you hear a story about a lieutenant who goes into a grocery store with a gas leak, with a 4-gas monitor, comes out, the chief's sitting in his car, and he goes, yeah, there's something wrong with this meter. It won't reset. It says XXX, and hands it through the window to him. And the guy's like, is this inside the store? Yeah. Now here's a lieutenant, full-time lieutenant, probably drilled 100 times. And I'm not putting him down per se, but he thought the meter was broken. He walked into a grocery store full of people and it was 100% LEL. And he didn't know what this thing was telling. That's a true story that happened in the suburbs of Chicago, and I told it a million times. He just didn't know. And the other night, we finished this class, and these guys were all sitting there, and these were not dummies by any chance. And they had MSA meters, and no one there knew that at 100% LEL, it said 3 X's. They just didn't know, because number one, it doesn't normally ever get up to that. And when you do a drill and stuff, you never normally get that height, but you gotta know what that means. So find out on your Draeger. It says,
Yeah, I'm reading it. Online.
yeah, just it'll tell you if there's a latching alarm. What 100%? It might just say 100%, but MSA went to latching alarms years ago, just to keep people safe. You know. Any questions? Any questions on your meters? Or I appreciate you having us out, and I hope you picked up a few pointers or some science terms. You know, these are free. If anyone wants one of these, you can get right to NIOSH. You write to NIOSH and write them a note and say, I'm a fireman in Watertown. I want a NIOSH guide. They'll mail you this for nothing. So these are free from the government. You should have, there's a current one. They don't change a ton, but every chemical's in here. And all the science stuff we talked about, it's all in here. Time-weighted averages, the vapor density, all that stuff. You know, this is a nice book to have on a rig. Beside the ERG and this, you can get a lot of information. Where is it at in the Rock River? Is it floating on the top or is it at the bottom? This book will tell you without being a hazmat guy. There's a lot of you that are probably like, and I don't know. There's a lot of people like that. Hazmat's not my thing. And I understand that, but it's not as hard as you think. I've been on hazmat incidents where they'll call back to this and say, oh, the pH of the stuff on the pH paper is 3. And I've had guys in the science thing with me, we're looking the stuff up and, you know, calling Chemtrek or whatever, and someone will say, oh, 3, it's real low. Is that an acid or a base? pH low, 3. Is it an acid or a base? It's an acid. Okay? Don't feel bad if you were like, oh, it's low, it's a base. Because what does your mind think? Higher number would be acidic, right? Lower number would be a base. It's the opposite. pH is the opposite. And there's technicians with tons of time who will screw that up. Very easy to do. And it's not that, you know, there's a little tube that comes with the pH paper. Hold it up to that and say, oh, it's a 3, and it'll tell you acidic or base. The lower the number, it's acidic. It's an acid. The higher number, how I always remembered it was, what does pH stand for? Probably no one knows. Power of hydrogen. How much hydrogen is in that compound is the pH, the power of hydrogen. Okay? The higher, more hydrogen, the more alkali it is, the more base it is. Okay? The lower, the more acidic it is. But it's something that people screw up. I've been on a hazmat incident where the dispatch will say, give us the, you know, what's the wind condition? What's the weather? What's the wind condition? 45 degrees, the wind is west at 10 miles an hour. And I've seen incident commanders say, all right, it's out of the west at 10 miles an hour. Is it out of the west or is it going west? And someone will say, no, it's west, it's going west. The wind, When they give you the weather and the wind, what does that mean? It's southwest at 10. That means the wind is coming from the southwest to the northeast. But don't feel stupid because you just screw it up. You hear southwest, okay, so we want to be southwest because then we'll be, it's very confusing, and we don't do this every day. We don't do it all the time. We're not industrial hygienists. And then they throw all this shit at us at 2 in the morning, and you're supposed to figure it out. I went on an incident one time in a suburb, and this big alarm was going off at like 1:30 in the morning on this building we ran auto aid with, and the building was a medical, like, radiation company. They sent out the sources in the morning to different labs for doing cobalt treatments and all that kind of stuff. And there's this big box there, like twice the size of that thing, with a big red light. There's a horn, like super loud. You could hear it a half a block away. So we got all these rigs there, and we're like, holy shit, there's a radiation leak or something. No one would go near the building. They call the hazmat team. They box it to get all the equipment for the hazmat team. We're there for maybe 45 minutes, and there's all this shit showing up and lining up on the street. And the guy shows up from the company, and he's like, his hair's all messed up. We're like, buddy, that alarm's going off. He's like, oh, that's a CO alarm. Because that's where they back the vans in to get and we had the high levels of CO coming in the door, so they made us put that in. It was a CO alarm going off, but we thought it was a radiation. We had all this stuff lined up. You feel like a complete idiot, but who's going to go in that building thinking it's a medical radiation and there's radiation things on the outside of it? There's an alarm going off. CO alarm.
Yeah.
So don't feel bad. I mean, no one should ever say, oh, you're stupid. You're not. You're just, stuff gets thrown at you and you have to figure it out. And these things will help you do that. These will help you do it. pH paper will help you do it. And it works. So, okay? All right, it's 3 o'clock. We're done. And I appreciate you having this many guys on here, giving me all this time.
Thank you.
No problem. Glad to do it. Easily.
I found it.
Oh,
I was hoping somebody hit record after we left.
Oh, I guess they're over. Yeah.
you found the dragger? What does it say?
There is a latching alarm. Matt, do you wanna come look at this and tell me if this symbol would make sense on yours? I just looked, and it's under Drager's. So that's a blocking alarm, so I'm assuming you would see that in the percentage LEL, it would just be like that symbol. But it will not shut off until you, do a fresh air setup.
Oh, jeez.
So,
So it stays on, like locks
until
it,
you're
big time,
outside,
right?
like, in fresh air, yeah.
Yeah, ours you have to
So
turn the
that's
meter
what that
off,
would
go
look like.
outside,
Yeah.
and then restart it, and it'll clear it. The latching alarm. So most of them have a latching alarm now.
Okay.
And they do that because these are worn out with workers, like guys going to ExxonMobil, whatever, they put this on in the morning. They'll just keep hitting the reset. They're doing their job, they don't care. So latching alarm, you can't reset. It'll make you get out. So there's a reason they do that, to be annoying. It's like a pass alarm.